this video is on Loci, or Loci, not too sure, and then I got a little bracket here, Loci annoying, because it's quite faffy and we use things like compasses and protractors to construct things. So if you like making, constructing things, this is definitely the must topic for you. So the first part we're going to look at is points. So I'm going to write what we're going to look at and then I'm going to get some paper I'm going to construct. Okay, so the first thing we're going to do is the locus of points, a fixed distance away from the first bit, a given point, and the second bit, a given line. So I'm just going to get some paper. Okay, so I have a fixed point, and I want the locus, so the set of points, basically that means an equal distance away from that point. Okay, so firstly I'm going to specify the distance. Okay, so here's my fixed point. That could be anything, that could be a friend, that could be a tree, whatever, and I want the locus of point 7 centimetres away from my fixed point. So firstly, if we were just thinking of using a ruler, what would this kind of look like? So I would be drawing, I want to be 7 centimetres away, but I want all the options. So I would be 7 centimetres away here. I would also be 7 centimetres away here. And here. And we could keep going like that, but as you can see that's quite faffy. How many points am I going to end up drawing? So, if you kept filling in that, you might notice it looks a bit like a circle, and 7 centimetres is your radius. So the way to do this is you grab a compass, one of the sharp things, and you don't stab someone because it really puts people on edge, and you want 7 centimetres away. So you get the scale as 7 centimetres. Like that. So this now, that gap from there to there is 7 centimetres. Now I'll put that on my point, and I draw a circle around my fixed point. Now on this line, as you can see the points we just drew, everywhere on this line is 7 centimetres away from this point here. So that is your locus of points 7 centimetres away from a fixed point. It's just a circle. So it's kind of showing that you can't just pick one point, there's actually multiple options. So now we'll do the example of a line. Okay, so here we have a line AB, and we want the locus of points, which kind of means the set of points, a fixed distance, and we're going for here 6 centimetres from the line. Should probably specify the line AB. Okay, so if you were just thinking about that before you even kind of knew what to do about loci, you would think, okay, I want all the points 6 centimetres away from this line. So you might get a ruler and start marking some of those points. So we can see there's 6 centimetres away. As you can see, this is really time consuming and faffy, not really ideal because that's only got some points and there are many, many points. So the way we do this is, again, we can use a compass, and we set our compass to 6 centimetres because it specified 6 centimetres. There we go, our compass now, so this width here is 6 centimetres. And we go to the end of the line, and we draw a little, because now we know all these points are 6 centimetres away from the line. We go and do that on the other side. So that's sorted out the ends. These middle bits are simple because it's just like drawing a line, so you can find a point that is 6 centimetres away like we've done here, and then just draw a straight line because we have a straight line. So now we know that is what it looks like, a bit of a sausage. So basically, if you think about it now, if I put myself here, I'm 6 centimetres away from the line, which is what I wanted. If I put myself here, I'm 6 centimetres away from the line because that's how I set my compass. So anywhere I put myself, this thing is dangerous, I nearly stabbed my toe. Anywhere I put myself, I'm 6 centimetres away. So that's how you would do it for a line. So they're not too bad and they have a very similar approach. So now we'll move on to a different kind. Okay, so this is the type 2, so we have equidistant from and then 2 given lines and 2 points. So first of all we need to understand what equidistant means, and that means, as it kind of sounds, equal distance, but just put into one cool word. So we need the points that are equal distance from, the first example will be 2 given lines and the second type will be 2 points. So let's have a look at that. The set of points equidistant from these 2 lines. So if I was just going to think about that before actually thinking about doing it that accurately, the points that are going to be equidistant are going to be somewhere in the middle here that are always going to be the exact same distance from there and distance from that line. So it's going to be some line in the middle, but that's not really good enough because we're doing this quite accurately and we're constructing it. So I'm going to get my compass and show you how this works. So the first thing you do is you get your compass on this point here, and you make a little, you can set it to any width you want this time, obviously let's not be ridiculous, and you do a little dash here. And you do the same on this line here. So I'm going to mark that as step 1. So those 2 there are step 1. You then, without moving the width of your compass, so keeping it exactly the same point, you take it from this point and you put it on the dash you've made, and you make another one. Don't worry, we're not going to keep doing this forever. You do the same thing on the other dash and make another one. And as you can see, they should cross. So don't make it too tiny because it'll just make your life difficult. And that there is step 2. So remembering to keep the width of your compass the same. Then you grab a ruler and you just draw a line that goes through that point there, that step 2 point. And that there is your answer. So that line there, so wherever I am on this line, if I'm here, this distance to this line is the same as the distance to this line. If I'm here, it's the same. If I'm here, it's the same. So anywhere along this line, I am equidistant, equal distance from this green line and this green line. Okay, so on to the next one, equidistance from 2 points. So instead of equal distance from 2 lines, we're doing the equal distance from 2 points. So the way this works is you're going to start on 1 point. So step 1, put your compass on, let's say A for this, and then you're going to set it again to a distance you like within reason and do a little dash. And you're also going to do that same dash on the other side, and then do not change the width of your compass. So this was step 1. You then go along to the point B without changing the width of your compass, and you do exactly the same thing. And as you can see, they should cross. So that's step 2, which looks exactly the same as step 1 because it kind of is. Okay, and now you draw a line through where those 2 points cross, and that's your answer. So that is the set of points that are equal distance from A and equal distance from B at all times, and that's how you do it. So it's not really too bad. So if I'm here, I'm the same distance away from A as I am from B. If I'm here, I'm the same distance away from A and from B, and here and anywhere along that line. Okay, so for the angle section, firstly we're going to learn how to construct a 60-degree angle without just using a protractor. Then we're going to construct a 90-degree angle without using a protractor. And then the third part is a perpendicular from a point to a line, which will make more sense when you see it. Okay, so I'm going to construct a 60-degree angle, like off this line, without using a protractor. So, goodbye. Okay, so the way this works is you go to one end of your line and you kind of spread your protractor out and you do a little dash like we always seem to do. You also do it here. So that's step 1 and step 2. Step 1, step 2. You then, there's only one more step, keeping your compass, that's what it is, the same distance apart. You go to step 2 and you draw another line. And these should actually cross, so I'm going to have to go back to step 1 and make this a bit bigger. Don't worry if that does happen. Happened many a time. So you've got step 1, step 2, same distance apart, move your compass, step 3. Now where these two cross is where you draw your line and then you've constructed your angle. So that is now our angle we've constructed, and that will always be 60 degrees, which I think is kind of pretty cool. You might not, but I'm going to have to do it for your exam anyway. Now let's just do a quick check. So let's get this protractor. And yeah, as we can see, that is 60 degrees. So I can confirm this does actually work. Okay, so we're now going to construct a 90-degree angle, also known as a right angle. And I'm going to go from this point here. So step 1 is this. Again, do the same as the thing we did for the last point. Get it a certain distance apart and go mark 1, a little mark, and do it on the other side, mark 2. So that's step 1. So this is step 1, and that's also step 1. The next thing you do is you move your compass to one of the points here, and this time you might actually have to extend your compass. This is actually allowed this time, and do another dash up here. Do the same things, this time do keep it the same though when you go over here, and do another dash. And then you draw a line from your point through there, and then that's your 90 degrees. So there we have our angle, which is 90 degrees. So the important thing to remember here was that was step 1, this part was step 2, but in step 2, warning, you can increase compass width. Another really important thing to note with these angle questions is, if you think about it, they can also ask you for 2 more angles. They could ask you for a 30-degree angle or a 45-degree angle, because these, the 30-degree is half of 60 degrees, and this one is half of the 90 degrees, which means you have to chop this angle in half, which we have actually done. And that was in the example where it's equidistance from 2 given lines. So the way we did that was, so this is very important, so if they ask you to construct a 45-degree angle, you construct a 90 and then you chop these 2 lines in half. So this is the equidistant equal distance from 2 lines. So the way we did that was either go back, or you get a little dash here, little dash here, and then without changing the width of your compass, you go on to the lines you've marked. Now if you draw a line straight through that, that will be cutting those 2 lines in equal distance, so you know that this then is 45 degrees. And you can do that for the 60 example. Okay, so this is our final one of this angle section, and it's a perpendicular from a point to a line. So perpendicular means 90 degrees. So you want a line that then is going to cut this at 90 degrees. So it is very similar to creating our 90-degree angle. So let's have a look at what you do. First thing you do is you set your compass a distance apart and you put it on your point. And you mark a point on this side, bam, and you also do it on this side. So that is step 1. So very similar to the last 90-degree angle we did. So instead of taking your point from on the line, you take your point from away from the line. So that is the only difference between these 2 examples. For the 90-degree one, we did it from there and would mark, and went up here. This one, you go from a different point. So it's just, yeah, that's the only difference. Then you put your compass on that point and you go, again, you can make this bigger if you need to, but my compass actually can't get any bigger. So mark a dash there, do it from this point too. And then where that crosses and your point, you join them up, and then that's going to cut the line at 90 degrees. So that is 90 degrees, which shows that it is the perpendicular from the point to the line. So that one is very similar to the 90-degree angle one, as you can see, because it's creating 90 degrees. But instead of going from this point on the line, you go from this point there. There are 2 types they will ask you to construct. Either it will give you the first type, all lengths. They want you to create a triangle and it'll give you 3, specify 3 lengths, and you have to make that. Or it'll give you 2 lengths and an angle. So either it gives you the 3 lengths to construct a triangle, or it'll give you 2 of the lengths and an angle. So we're going to look at the first type, where it gives you all 3 lengths. Okay, so this is asking us to construct a triangle ABC and then it's given us 3 lengths. This is the first time, all lengths. So it's asking for AB to be 10 centimetres, AC to be 7, and BC to be 4. So the first thing we do is we're just going to draw one of those lengths with a ruler, AB, as 10 centimetres. So I've got my ruler here. So this is 10 centimetres. I'm going to call that A, that B, and we've ticked that. AB is 10 centimetres. I want AC to be 7 centimetres away and BC to be 4 centimetres away. So this is when you bring in your compass. So next step, bring in your compass. Bearing in mind, I know I want AC to be 7 centimetres. I get my compass and I make the width, the length it's asking for, 7 centimetres. So that width there is 7 centimetres. And I go from A and I mark. So these are the points that are all 7 centimetres away from A. So C is going to be at some point on there which is 7 centimetres away from A. What about, so that's step, kind of step 2, but I'm going to call it step 1 for the AC. So C is somewhere on that line there. What about BC? So BC, so that means C is basically 4 centimetres away from B. So if I draw, you get your compass, get the width as 4 centimetres and draw from B a line 4 centimetres B. So you know that C is 7 centimetres away from A, so C lies on this line at one point, and C is also 4 centimetres away from B, so C also lies on this line at a certain point. So as we can see, the only thing that actually satisfies both of them is where these two lines meet. So C is going to have to be here. So now you just join it up and you construct your triangle. So there we go, now we have triangle ABC. You can check if you want, but if you measure these, we measured that first one, so that is 10 centimetres, this was 7 centimetres, and this was 4 centimetres. Okay, so this is a type 2 because it's asking us to construct a triangle, but it's given us 2 lengths, 7 centimetres, 5 centimetres, and an angle. So the way we do this, we do the same start. So we're just going to start with this length here. So we want AB to be 7 centimetres. So I'm going to find 7 centimetres on my ruler and draw a line of that length. So I'm going to call that A, and that is B, and we know that is 7 centimetres because we just measured it. Now, we know we want BAC to be an angle of 50 centimetres. So this is when you can actually use a protractor. So for this one, you can use a protractor. And okay, so let's work out which angle we actually want as this though. So we're going to have the angle BAC. So it's going to go BA and then C somewhere up here. So it's going to be this angle here because you take the middle one. So BAC, so it's in the middle. Get your protractor and measure 50 degrees. So that is here. So if I now draw a line there, I know that all along this line here, the BA, soon to be C angle, we know that that angle there is 50 degrees. The only thing we need to do now is establish where we're drawing, how we're finishing our triangle, and we can do that by looking at AC has to be 5 centimetres. So simple use of a ruler here, you know A to C is 5 centimetres, so you measure 5 centimetres from A, and we know it has to be on that line, so that's why we just did that step. So that must be where C is. So we know where C is, so let's just join it up to B. So that's how we do the second example where you have 2 lengths and an angle to construct a triangle. You just use a protractor. Okay, so this is our first exam question, and it's given us a little sketch of a little triangle, and it says draw an accurate drawing. So if we look at the information we've been given, we've got 2 lengths, 7 centimetres, 8 centimetres, and an angle. So this is the one where we're going to use a protractor. So firstly, we're going to draw the line AB and make sure that that is 8 centimetres. We're going to call that A and that B, and then that we know is 8 centimetres. Now we need to deal with the angle, so we get a protractor, and we're looking for 43 degrees, which is like quite a random number, I thought, but you know, if they want that, that's what they'll get. So that is 40, and then 3 is about there. So we know all along, if we draw a line here, all along that line, that angle is going to be 43 degrees. And now we just need to know where to stop that line. And it's given us this 7 centimetres. So we know from A to C is 7 centimetres. So if we measure that, so if we join C to B, we've constructed our accurate drawing. Okay, so this is exam question number 2, and it says draw an equilateral triangle, sides 6 centimetres. So what do we know about an equilateral triangle? All sides are the same length, so that length is 6 centimetres, and we also know all angles are the same. So what are all those angles? We know that we have 3 angles, so we're going to call them 3 x's, and they all add up to 180 degrees. So that means one angle is 180, take the 3 down, divided by 3, 60 degrees. So all angles are the same, 60 degrees. Now that immediately rings alarm bells in my head because I know that one of my criteria is to know how to construct a 60-degree angle. So first of all, let's draw the bottom end of our triangle at 6 centimetres. Now I need to create an angle here of 60 degrees and an angle here of 60 degrees. So I'm going to use my knowledge of constructing 60-degree angles to do so. The way that was step 1 was to draw a little dash up here, and you also had to do it, then you had to move your compass onto the step 2 and draw another line, and where they cross, so all along that line is 60 degrees. Let's do a little check and measure the angle. Yeah, so you're not actually allowed to use a protractor, but it's a nice check. So that is 60 degrees. We know that this is 6 centimetres. We know that this line also has to be 6 centimetres. So let's get the ruler. So that is 6 centimetres. Oh, we've had a bit of a chaos splurge there. And then now we don't actually have to do the other side. You can just join those 2 up, and I might just want to check that it is 6 centimetres. Yep, it is. And yeah, all those angles here then are 60 degrees. So that is constructing a triangle and using the how to construct a 60-degree angle knowledge. Okay, so this is the next question. Construct a perpendicular bisector to the line segment AB, so this is your line segment, through the point P. So what we need to know here is that a perpendicular bisector, perpendicular means 90 degrees. So we kind of want that 90-degree angle, and if you draw a line, that's going to be cutting it perpendicular. So the way we did this was we started from point P, we know it has to go through point P, we did a little dash here, and we did the same on this side. So this was for constructing a 90-degree angle. Then you could make this bigger, this is the one you could actually make it bigger, and you went on to the points you've drawn, and you drew another line, do the same on this side, and where they cross, if you draw a line from the crossing to P, that should be a straight line, 90 degrees. You can also do it on the other side maybe, just to get, so how big was this? But there. Do it down here too, just so, because I didn't trust myself to draw a line that, actually that's straight. So draw that up, we know that that's 90 degrees, that's 90 degrees, so that is a perpendicular bisector, because it's perpendicular and it's bisecting the line. Okay, so this is the next question, and it says construct the bisector of angle PQR. So we're kind of splitting this in 2. And the way we did that was the example that was equidistant from 2 lines. So if you go back and watch that, the way you do that is you do a little dash here, little dash there. Without changing the width of your compass, you move on to the dash and do another dash. Do the same for that line. And then where they cross, you draw a line through that, and then that is exactly splitting it in half. Okay, so that's all the how to do loci and then a few exam questions. So I hope that's now clear and you can have fun using your compasses for once.